Okay. Good morning. Good afternoon. Good evening. In some cases. Dimitri, good to see you again.
Good to see you too, Pete.
How's Amsterdam treating you?
Very well. It's nice and sunny these few days, which is rare, but yeah, we get to enjoy a few days of
Good.
sunshine.
Well, sunny in Amsterdam sounds good to me. I'm in not sunny Seattle, so that's but I'm used to it. Good. Well, welcome to Edge AI Talks, everybody. We are going to dig in to some Renaissance sensor topics today, which is pretty cool. And talk about bikes, talk about smart bikes.
Bike chains instead of tool chains.
Yes, bike chains instead of tool chains. But welcome, everyone. I think this is live stream. So we're on YouTube, we're on Facebook, we're on Twitch, we're on LinkedIn, StreamYard. So feel free. Please let us know where you're dialing in from. I see we have George from Malaysia. Thank you very much. We have Alex from the UK. Excellent. Michael from San Francisco. And we got more and more folks coming online. So awesome. So yeah, you'll have a chance. Just feel free as Omar is talking. You can just like throw questions in the chat. Dimitri and I will kind of monitor those and we'll sort of cut in and get things answered because that's what it's all about, learning about new stuff. That's why we're here. Couple of public service announcements. Let me, first of all, we have this event coming up. Well, there's lots of things going on, actually. I guess if you're in Austin, Texas next week, there's the Microelectronics Show in Austin. And I know Edge Impulse is going to be there big time. But we'll be there as well. So definitely check that out. And then in May, Sensors Converge in Santa Clara. Speaking of sensors, good show. Show's been around for like 40 years, which always blows my mind. Like, what were they doing 40 years ago? I don't know. That first show. Sensors.
At that time, yes.
Temperature sensor. So that's going to be a really good show, May 5th through the 7th. And we'll have lots of Edge AI community there. And I'm going to do a keynote called How Edge AI Will Save the World. So you want to check that in because something needs to save the world. Might as well be Edge AI, right? So check out that keynote. And then we're going to do our event in London. Edge AI London 2026, June 8th through 9th. And let me play you a little cool little video. Hold on for a sec. Wow, there you go. Pretty intense for the morning here. So yeah, check out the Edge AI Foundation Edge AI London 2026 show. So check that out. That's a good one. The other thing, by the way, I'm going to talk about too is we have a new wiki that's up. So if you go to wiki.edgeaifoundation.org, all of our working groups have their work product and their meeting minutes and all kinds of stuff that they're working on with its audio and generative Edge AI and things like that that's happening. So we have like 9 different working groups. So if you go to the wiki, you can search that. It's free. You can also subscribe, put your email in, get subscriptions for when there's updates in different working groups and stuff like that. And then the final thing, because I know everyone's like, let's get to the bike already, is we have the Generative Edge AI Working Group has a live stream next week. Two-day live stream of tech talks on generative and Edge AI, agentic, physical, everything that's happening basically with language models on the edge. I think it's like 2 full days of talks. I mean, it's going to be who's who. So go to our website. You can subscribe to our YouTube channel. It'll be on YouTube as well. So that's happening next week. If you want to kind of catch the latest, what is state of the art in terms of language models on the edge. So that's next week as well. Yeah, so that's about it. Dimitri, I mean, what's new in your world, by the way?
That is a really good question. Yeah, I mean, what you actually mentioned would be very relevant, the generative AI on the edge. I will definitely listen to those talks over there because that's hot. And yeah, that's actually what I've been working recently for Edge Impulse, like the influencing side in
Mm,
SDK.
mm,
We're about to release developer preview of that as well. So basically, just yeah, related to VLMs on the edge. By the way, coincidentally, you mentioned the London Edge AI event.
mm.
95% confidence I'll be there talking about VLMs on the edge.
That's
Yeah.
true. Yeah, I saw you on the agenda. So yeah, go see Dimitri in person, IRL.
Exactly.
Awesome. Cool. Well, let's bring on Dr. Schritt. Omar, welcome. I think your microphone. Oh, there you go. You're
Yeah. Hi, Pete. How are you doing today?
good. Good.
Hello.
Perfect. Dimitri, how
Long
are
time.
you? Nice to see you.
Nice to meet you.
Yeah. So, fun fact: you guys used to work together at Edge Impulse.
Yes.
Small world.
Yeah.
Right, as the Edge AI world can be. But yeah, welcome to the live stream.
Perfect. Thank you.
To
Thank
give
you
us
for
a little
having me.
background, of yourself and your story here in Renesas, and how did you get to Renesas, and what's your area of focus?
Yeah. So my name is Omar. I work at Renesas in product marketing. I'm basically a staff engineer, and as we say, it's a small world. Everyone knows everyone, and in the past, before Renesas, I used also to work at Edge Impulse. I was mostly focusing on customers and solution engineering, where Dimitri actually he was mostly working on the embedded side of things. Still perfect, amazing. While right now still engineering, but mostly moved to product marketing, where it's very interesting to see how we can basically, our target is to take all of these AI and AI models and see how we can, let's say, fit them into this embedded hardware. And this is what we do every day. We get always to new use cases. We hear about new stories. We see like, what can we help, how we can help our customers, how we can improve our products, and so on and so forth. So this is how it is, and that's how it's going.
Awesome. Well, yeah, we're looking forward to it. You gave us a little preview before we went live, so lots of interesting developments on the tool chain side, and as Dimitri said, on the bike chain side. But we'll get to the bike thing at the end. Actually, interesting, Dimitri, you probably have bikes on the brain because in Amsterdam, everyone has a bike, right?
Some people have two. Like sometimes you just leave one at the subway station where you need to get off.
Nice.
Yeah, definitely. Amsterdam is, let's say the hub for bikes, where everyone actually is using the bike more than anything else. So it's the primarily, I would say, compute tool that you have, basically, which is your bike. And I think e-bikes also are getting famous in Amsterdam, or it's still like not the same, because I remember that it was not possible to use like the scooters, which was not allowed.
E-bikes, yeah.
Nah, scooter, like the Segway thing, still not pretty much. But the e-bikes, yes, for sure. Just the regular e-bikes that cannot go over 25 kilometers per hour.
Fair. Pretty fast. Yeah. Yeah, there's a lot of regulation in the U.S. too around e-bikes and bike paths and all that sort of thing. But yeah, it's pretty cool. I took an e-bike. I was in Verona last year, toured around, and I was on an e-bike, which was pretty cool because we could go way up in the hills and stuff. So, but anyway, we'll talk about bikes. Let's get started with what you want to talk about, and I'll remind the audience. Let's see. Here we got Tom from Charlotte is here. We've got Alan from San Diego. Speaking of nice weather. Cool. So we'll get you going here. And then as folks want to ask questions, just put them in the chat and we'll get to them. We'll probably bundle them up. But
feel free, whenever you have a chance, like feel free to interrupt me. We can always discuss the questions immediately in real time. Let's make it as the talk instead of a presentation is going to be, I think, much smoother for everyone.
We will interrupt.
Let me start.
So let me. We'll give you the floor, and then you can dig into your stuff here. Hold on. Let's see. You can start.
All is good. Nice.
Go for it.
Perfect. Thank you. Great. So, welcome everyone. My name is Omar. I'm staff engineer in product marketing at Renesas. Today, we're not going to have like a deeply technical talk, but instead, we're going through, I would say, a practical guide. What I would like to show you how straightforward it is to go from real-world sensors, from the signals that they are collecting from these sensors, to immediately to bring this AI to your intelligent edge devices. And these devices, we can make them intelligent with a set of tools that we are going to show you today. So we are going to go through a bit of our software tools, our compilers, our ready-to-use hardware kits, and eventually we are going to discuss the eBike, as Pete and Dimitri has mentioned. So yeah, let's start and let's see. And feel free if you have any questions, you can talk to them during the presentation. So AI in itself, it's not, I would say, a standalone features, but it's becoming more and more something that is across the entire IoT sphere, where basically, if you'd like to build, let's say, a motor controller, if you'd like to build human-machine interface, or work on some kind of sensor fusion system, all of these devices, they are using now today AI to enhance this existing functionality. And at Renesas, we have, I would say, 3 pillars for AI. The first one is voice, the second one is real-time analytics, and also we have vision. These 3 areas where Edge AI delivers the highest customer value, and you can see that across all the market segments that we have, whether if it's for the consumer market, whether for it's the healthcare automation, or also the agriculture and industrial automation. AI can improve basically the features of these, but such as the maintenance, safety, or personalization. And it's these days, I don't think that AI itself, it's not a nice to have anymore, but it's becoming more and more a competitive differentiator, and it's becoming essential of having it inside the product. So today, what you're going to do is basically talk about our reality AI tools, and this is what I will call our AutoML tool, that allow us to build our AI models to non-AI experts. The second thing, actually, we are going to jump into RUHMI compiler, where we're going to get this model that we have produced with the reality AI tools and compile them into our, let's say, AI accelerated hardware to make the inferencing more efficient. Eventually, we're going to show you a set of our hardware kits, and finally, we are going to discuss the eBike application, how this real-world concept, we can tie all of that together, so how we can integrate the sensors, the hardware, how we can combine it with the software and put all of that on the eBike. And, basically, all of that, it's a journey. So we are going to start from the initial steps, which are the data. Then we are going to jump to the model, then to the hardware. And then we are going to assemble all of these to have eventually, I would say, a working product or a concept that you can use, where you have combined the AI into your product. So the question actually we are trying to answer today is the following, how do you actually build an AI model for an embedded device without being a data scientist? And to do so, internally at Renesas, we have the reality AI tools. And the Renesas Reality AI tools is basically, I would say, it's the cornerstone, it's the centerpiece when it comes to the Edge AI offering. And we are going to emphasize on 3 pillars. The first one is the machine learning model development, where we are going to build the model from this sensor data without the need to have any AI expertise. And we have a feature called the AI Explorer, and we are going to talk about that in a while. The second thing is the explainability and the hardware analytics. And it's what's nice about the Renesas Reality AI tools is the fact that it allows you to understand your models. It shows you how AI is happening. You are able to make decisions. So basically, you can see in real time actually the entire pipeline is visible for you, and you can see how the entire thing is being built. And eventually, we're going to provide you not only with the tool, but it comes with, I would say, a reference design or application examples So you don't need to start from scratch, but instead you can already leverage from what have been already provided or proven. So this tool is basically, it's a production grade tool. So engineers can use it, and also they're using it today. Our customers are working on it to build, let's say, real products. So the AI is being integrated directly into the real products, from predictive maintenance, condition monitoring to smart home appliances. And this is happening on the cloud, but before that, I would like to highlight for you the general AI workflow, which I think every one of us who has been involved in the AI have very well understanding of how this is happening. But I would prefer just to iterate on it and go over it a second time. So the first step, basically, if you'd like to build your AI model, is the dataset, and this is the most important thing. And when you will need to collect your dataset, it needs to be a clean dataset with the lowest amount of possible noise. In the second step, you usually you need to label your data. It might depend on your use case, where in some cases, labeling data is not necessary, especially, for example, if you're working on cases where unsupervised learning is necessary, for example, anomaly detection and similar use cases. But after that, once you have your data, it would be interesting to do some kind of data analysis and to do some kind of visualization of your data set, just to ensure that nothing has been collected in the wrong way and everything is correct, and eliminate any possible mistake during the dataset collection. The next step is the training of the model, where you'd like to train your model to achieve a certain accuracy that is you are satisfied with, and it's good for your product. But if the accuracy is not good, you might need to do more investigation, and eventually you might need to recollect dataset again. But if the model is good, then you can jump immediately to the next step, which is the deployment and the testing of the model. So if you are deploying the model on your hardware, it's perfect. You can give it a test, and this is the test is going to be coming from the field. So it's like the real validation from the field. And here, where you can be sure that the accuracy of your model is exact what you're looking for. So all of these steps are very generic, and they're across all, let's say, embedded AI. They're more or less the same. But it's really important to highlight them before going to deeper discussion today. So what I would like to do right now is to have walkthroughs through like the typical AI development. So what we have is the Reality AI tools, as I mentioned before, but it's really work closely with the eSquare Studio. So both of them are really connected, more or less. Whereas the Reality AI tools is more on the cloud-based tool, and it talks directly to the eSquare Studio, which is the Renesas IDE, and it's installed locally on your PC, your development device. And the eSquare Studio is going to, provide for you everything you need to build your firmware, and to do the entire part of the hardware, let's say software development for your hardware. And it has also something related to the Reality AI tools, which is we call the Reality AI utilities. But if I would go one step back to the Reality AI tools, I mentioned before the AI Explorer, and I would like to highlight more regarding that. So it's basically an AutoML. So you don't need to do any tuning for your neural network, but instead the tool is going to tell you, we're going to provide the data, and the tool is going to provide you with all these models and tell you, I have found the best model for you. And given the hardware constraints that you have defined, I think this is the model that is going to be suitable for you. And then you're going to download the model, integrate it into your eSquare Studio, into your firmware, and eventually deploy it on your hardware. So this is how these two tools are connected together. And from sensor selection perspective, because we're referring to sensors today, and BOM optimization. The tools itself can help you to figure out actually which is the sensor that you actually need, because you have all the feature set collected from your sensor. And eventually it might tell you that, oh, well, sensor A is very important and sensor B is not adding any value. So basically you can eliminate sensor B, and eventually you will have your BOM actually reduced, and also it's reducing your cost and giving you the highest advantage at your sensor. So feel free, to interrupt me anytime if you have any questions. I would like a bit to highlight the React AI utilities. So this is the one that are integrated as part of the eSquare Studio, but this not only actually you can have them separated. We are going to see that in a while. And the data storage tool is the first one, where it allows you to collect your data set live from any Renesas MCU, and you can directly it's not necessarily related to your own like evaluation kit, but instead, if you are building a product and you have Renesas MCU on it, you'll be able to collect data set directly from it. And then you will have the AI Live Monitor. So you have deployed your model into your Renesas evaluation kit, let's say, and you would like to get the results in real time. You would like to see what's happening. So this is where the AI Monitor comes in. It allows you to debug in real time, and it allows you to see the results, so you can gain confidence immediately of the performance of your AI model. Finally, we have what we call the hardware in the loop testing. And here where you can, for example, evaluate the performance of your model by collecting data set from the hardware. But at this stage, the model does not need to be on the hardware, but instead you are working more or less on a simulation environment, where if you don't want to modify your firmwares, or the project is too big and you don't want to touch it, but you just would like to see, before committing to production, you'd like to see the performance of the model, then here where the hardware in the loop testing can be very helpful for you. So the main idea here basically is to make the black box of the AI transparent for you, and so you can see it, you can test it, you can use it in real time, and also you can trust it. So this is the tools. Actually, I wanted to showcase them.
We had a couple of questions we want to cut in, if you don't mind.
Yeah, right. Basically the warm-up stuff. So I had a fun question there. It's called Reality AI. Is there like anything behind the name? Is there a story, and what does it mean, Reality AI Studio? Starting from non-technical questions.
I wouldn't be able to answer myself personally. If I would deduce, for example, to know where the name is coming from, I think it's coming from the real-time analytics of the data, where the data is coming in real time, you're analyzing it, because this is where the tool eventually created. But I don't know this story itself, so I can ask the team if you'd like, and we can let you know.
Right,
I have a question. Go ahead.
No, it's okay. Go ahead. Yeah.
There's actually a question here from Gaming Clips WW8FU. Does your application or dashboard support XAI? I think it says explanations. Is that how do you want to interpret that question, or do you want to respond with another question?
Yeah, probably I would say actually, what is the XAI? Just to understand what it means.
Yeah, I actually Googled it when I saw the question. So XAI is explainable AI. So, I mean, how I'm understanding the question myself is that I think somewhere earlier you did mention something about like looking into why the model gives the answers it gives, something like interpretability of the model. Are there such things there or not? I think that's what it comes to.
It's a nice question, and here where it comes actually the thing behind it is that the models actually coming from Reality AI tools are not very, let's say, not very big. They're very small, and basically we didn't opt at the start to use, for example, something like neural networks. So we basically started with algorithms that are less complex to interpret the results. So basically, you're talking about classification algorithms, where you know how the algorithm actually basically work. where when you're talking about neural networks, you have more complex process to build the entire weight of the model. So it's related more to your, let's say, original data set. But if you use other algorithms that are not neural networks, you will have better understanding actually of, let's say, what's happening within the algorithm itself, because you can look actually at the implementation of it.
Okay.
So this is how I would answer it.
Okay, fair. Here's another one from Syed. You mentioned black box transparency. Are you also working in explainable AI in embedded systems?
So I think it's a bit related to the previous questions, more or less the same. Yeah, the idea here basically is to make all the steps for you visible. So you can visualize any of these steps when it comes to your data set. You can see the, your data set. You can analyze it. You can visualize the data set. Then the next step, you are training the model. So basically, you are getting the performance values, but also we are allowing you to immediately deploy the model on the hardware. And here's actually where the iLab monitor, where you can see in real time actually the output of your model, and you can see step by step what's happening. So this is where the explainability, I would say, regarding the performance of the model, you can see it in real time, and this is where we are trying to target in the future. And it currently exists, it's very well, but we are trying also to improve it day by day.
Cool. I had a question too about your compiler tech. Are you using any, I guess in any of the tool chain stuff, are you using AI itself for any kind of optimizations in your tool chain for compiling and performance?
To my knowledge, not yet.
Okay.
I have also one small question. Maybe it's going to be mentioned next in the presentation, but still, because you already hinted at some hardware and you had a picture of development board from Renesas. So I kind of wanted to ask, maybe is there a recommended dev kit or dev board that you would tell people, like what you want to, like, because different vendors have different boards, and if you take one, it may be really easy. You take the other one, it might be a nightmare. Maybe there is one that you would say that this is the one that you want to get from Renesas to get started with all of them.
We have actually a set of AI kits. So basically, we call them the AI kits. We are going to talk about it in the presentation later. So I'll explain all of them, and you can see which one that. I mean, you have different tiers, different, let's say, ranges. So I think each validation kit is more suitable to a specific use case or specific, let's say, project that you'd like to develop.
Right. Okay. Good. Well, we'll let you get back to it.
Perfect.
Thanks.
Yeah, so we're discussing actually the reality utilities. And here's where we have the three of them. And, they're part of the eScore Studio, but not only. You can have them as a standalone tools. And this is where the question is regarding how the explain the AI comes in. So you can try these ones, get the results in real time and see, are you satisfied with the results or not? If it could be improved or not, you can also let us know. I would be really happy to get feedback from our users, also from customers. We always get feedback, and we try to improve the tooling according to this feedback that we're getting. So feel free, to try them. Yeah. We have also another feature we have added last year, and I'd like to highlight here today. I think many of you know MATLAB, and you use it also in your workflow, because MATLAB is a very important and extremely well tool in the industry, especially when you are trying to start doing modeling actually for specific machines, or you would like to take your mathematics and theoretical parts into more, let's say, production. So what we did is, we created, let's say, a bridge between Renesas Real AI tools and MATLAB. And it allows you actually to use reality AI tools as usual. You are collecting the data, you're developing, analyzing the model with reality AI tools. But what we can do is export models to MATLAB. And you can use that for your custom validation and testing. And eventually you can deploy it on your MATLAB server. And you can see, how this is working with your MATLAB pipeline. And if this workflow is working for you and you like it, then eventually you can take the model and put it on the proper hardware. So this is like an intermediary step if you are working still in a validation phase and you're using MATLAB. So we got you covered there. Second, so I think we have covered now the cloud part of Renesas Real AI, which is basically the AutoMail part. And second part we'd like to talk about is the foundational software. And this is, we're going to talk about the Renesas RUHMI compiler. And, suppose you have trained your AI model. So, how you can actually, let's say, get the maximum efficiency of your model. And even, in a different way, suppose that you have your own model and you're bringing your own model to Renesas, and you have trained the models, you have your entire pipeline, and you have worked so hard to make your model perfect, and you like to put it on Renesas hardware. So how you can do that? Well, we have RUHMI. So RUHMI basically is the robust, unified, heterogeneous model integration framework. It's basically a compiler. And it's based actually on Edge Cortex Mera. And what we did is we have been working on, let's say, two things. The first one is a graphical user interface, and the second one is a command line interface for different kind of users. So the idea here is the following. Suppose that you have your AI models and you'd like to run it on your chip. And we know that these days, most of the, you have MCUs and they come like with several cores, correct? And it's becoming more and more, common to have, let's say, a neural processing unit, or what we call usually an NPU. And since you have like these multiple chips, you're usually keeping the main chip, which is the application core, to handle, for example, your firmware. And you would like to take the other part, and you would like actually to move it actually to a dedicated AI accelerator. So you have this dedicated AI accelerator chip, and you would like to move this AI model there. So RUHMI is going to figure this out for you, and is going to split the work across these two cores automatically. RUHMI itself, you can use it, for example, if you, as I mentioned before, to bring your own model. You've built your model in PyTorch, in TensorFlow, or you have it just in Onyx. And the first step would be is very easy. You have the quantization process. So basically, we are going to quantize your model to an integer 8. And then we're going to optimize your model by having, let's say, an intermediate representation. So basically, we're going to do partitioning, where the layers that are accelerated, let's say the Ethos U55, which what we have on the R8P1. These layers are going to run on the Ethos U55, and the layer actually that are not optimized or they're not part of the Ethos acceleration, they can run also on the CPU. So the compiler is going to decide by itself, and it's going to provide you, let's say, header files and .c files with binaries that it allows you to combine them with your firmware. You can compile the software again, and you can integrate it into your, let's say, RAP1, which is our MCU that has the Ethos U55 hardware accelerator. And the inferencing engine is going to take care of it by itself. So you don't need basically to be, let's say, a compiler engineer or have, let's say, deep technical details about how to separate all these layers and take care of them. Instead, we are bringing RUHMI here to take care of the entire process for you. The other thing here with RUHMI is how we can make it easy for the user. So basically, it's a 3-step journey. The first one is you need to download the packages from GitHub or Renesas websites. And I also added here a QR code if you'd like to try it. So it's already public, and you can download the package. The next step is you're going to install it. So you can install the GUI or the CLI. It also comes part, you need to do the installation. We have also the GUI interface covered in eScore Studio. So you can immediately hit run and try actually to take care of your model. Once you follow the steps here that I have mentioned in step number 2, from downloading the model to selecting it, optimization, and so on and so forth, then you can, let's say, compile the model and you can deploy it directly on the hardware. So the idea here is that the entire process, from downloading RUHMI, preparing your model to the deployment should happen in one afternoon. You don't need to spend, a couple of weeks on it. It's basically a very nice acceleration if you would like to do immediate testing on your accelerated hardware. yeah, so you have the QR code. Feel free to try it. The next thing is the interfaces. So as I mentioned before, we have the graphical user interface, and also we have the CLI. The GUI is available on Windows for now, and the destination is to provide it for beginners, where it guides you end to end. So basically, you can just select on next, and it guides you by itself. So you don't need to have any complexity building the model. However, the CLI tool is more complex, where if you are, for example, an engineer and working into a production pipeline, and you'd like to integrate RUHMI into your continuous integration or continuous testing, so you have your CI/CD pipeline, you can make it as a part of it. So it's going to compile the model for you every time you're going to push the code. And then you can immediately do some kind of local compilation and testing on your PC to check if everything is correct. You can basically run the inferencing on your PC. If everything is fine, then you can deploy it on your hardware accelerated device. So how we can build a demo for this, how we can do all of that. So we have an application example already available once you downloaded RUHMI and did the installation process. First of all, you're going to select the application example. Currently, right now, you can find a face detection model and also an image classification model. They are, let's say, a default model that are available with the package. You can also bring your own model, of course. Once you did that, you are going to download the model itself because it's not hosted within eSquare Studio. It's on GitHub. So the tool is going to automatically pull the model for you and integrate it into the pipeline. Then you need to click on Build the Project. Once the project is built, with no error or nothing, that you need to take care, then eventually you can deploy the project on the hardware. So basically, I would say it's 5 steps or 5 clicks from the idea itself to the hardware. And this is the experience we're aiming for. We'd like to make it very easy, actually, to our user to enjoy using RUHMI. Eventually, I would like to show you some performance because, since we are talking about the hardware acceleration and we have a compiler here, and I think everyone is interested to know what kind of performance I can get. And so we have the R8P1 MCU, which contains the Ethos U55 accelerator, and this accelerator is enabled by RUHMI. And on the left side, we have 2 models. The first one is a face detection model, and the second one is an image classification. And if you compare, for example, on the same chip, whether we are using the Ethos or not. So the first one, when you have the Ethos off, you will get 74 milliseconds of inferencing time. Well, when we have it on, you're getting down to 4 milliseconds. And this is providing you approximately, I would say, of 20 times, let's say, of faster time, inferencing time. So you are jumping up 20 times in inference. And this allows you to save the, let's say, your hardware by allowing the application core to target something else. So if you have a complex application, you can run the model on the NPU, and your firmware also run on the CPU itself. So you no longer need to add additional MCU in your product. One MCU can save you actually this, so we are reducing also the BOM and the time to market. So this is the application example I mentioned before when it comes to the R8P1. So this is an evaluation kit. It's also available on Renesas website. It has 1 gigahertz of CPU clock speeds, and it's powered by an ARM Cortex M85. So this is the first core, and also we have a second core, which is an ARM Cortex M33, and also it has a clock speed of 250 megahertz. And in addition to this, we have the Ethos U55 NPU, and it's running also at 500 megahertz. The kit itself actually is coming with the camera and the display, so you can use it directly if you'd like to try RUHMI. And one of the things here I would like to show you is the benchmark compared to the previous R8D1, where the R8D1, it's a similar processor, but it doesn't have the hardware acceleration. So we can see for the face detection model, we have a benchmarking of 126 milliseconds, where on the R8P1 also we are going down to 4 milliseconds. So, it's 30% jump in, 30 times actually jump in speed. So this is the part I would like to highlight today when it comes to RUHMI. If you have any questions, please feel free. I think it would be really interesting to hear your opinion and what do you think of RUHMI? Would you be interested in using it? And yeah. If no questions, then let's talk about the hardware part. So so far we have covered, I think, the software tools and the compiler. Now let's jump into the hardware. And yeah, this is the kits, what we call the AI kits. So we have 3 of them. The first one is the R8E1, and the second one is based on the R6M3, and the last one is on the R8D1. So the first one, if we will start actually with the high end, and the R8D1, it's Cortex-M85 also with the Helium extension. So it supports basically vision application, audio, and real-time analytics. And this is basically the kit that you would choose for your most demanding Edge AI applications. I've also added the QR code for each one of them, where you can immediately go to Renesas website by scanning these QR codes and look at the specification and the application examples that we have for each one of them. Also purchase, if you're interested in getting any of these kits. The second one is, I would say, the mid-range, where it's the AIK RS6M3. It's based on a Cortex-M4 running at 120 megahertz. It's great if you would like to work on audio application and real-time analytics. You will get very solid performance there, and it's also possible to do some vision applications with this kit. And the entry level would be the AIK RA4E1. It's basically a Cortex M33 running at 100 megahertz. This is going to be perfect for your audio and real-time analytics application. And it doesn't support any vision there, so this will be the entry point for you if you'd like to do any, let's say, audio or real-time analytics. We have also voice kit. So if someone is interested in, let's say, developing specific audio application where these kits actually have onboard microphones and sensors, we have 4 of these, and we can start from the lowest end, the entry level, which is the RA2L1 running at 48 megahertz, to the high performance one. We have running at the the MCU is the R8M1 running at 480 megahertz. We are here target. I wouldn't jump into the details of each one of these. You can immediately go to Renesas website and see each one of them. But basically, the low end ones or the entry level are destined for, let's say, voice command recognition models, and it allows you also to do speaker verification, identification. While the highest end boards are mostly for natural language understanding. So all of that is running on the device at the edge. You don't need any cloud dependency. Once you deploy your model, it's running directly on the hardware, no latency, and there is no privacy concerns when the model is running on these kits. Finally, now I think this is step right now is to talk about the eBike, and this is where we started the topic. But before jumping into the eBike, if anyone has any question regarding the hardware we have, or or RUHMI, feel free to interrupt me. I think it would be the best moment to do it right now.
Okay. Yes, we're going to get to the bike.
Right.
I saw a couple of questions here. Here's one from Syed around a question about RUHMI specifically, offering profiler analysis capabilities that identify performance bottlenecks within a model and make suggestions on what would benefit for hardware accelerated deployment. So what is RUHMI doing in that space in terms of kind of proactively or intelligently analyzing bottlenecks and performance?
So RUHMI is not going for, so RUHMI itself, it's a compiler. The tool is not going to provide suggestions. This is not the target of the compiler, but instead actually is going to do its best to separate, the layers and to maximize the hard acceleration. So if a layer is supported by the Ethos U55, then these layers actually are going to be, compiled to run on that specific NPU, and if not, then they're going to run on the CPU. It's trying actually its best by doing, let's say, quantization to increase the speed of the runtime even on a CPU, but the tool itself doesn't do any suggestions.
Got it. Question from Adrian before we move on. Can you talk about the power battery life on the platforms you just mentioned for audio or image recognition?
This is very complex thing to talk about. The reason for that is it depends on the application, basically.
Sure.
We cannot, tell, for example, how much the CPU is going to consume in real time. The answer to it, it depends on your application, basically. So we are trying always to, if you choose, for example, the entry point, for example, for the voice kits, then running on the RA2, you can expect to have a really low power CPU. But if you are using the high-end one and the power, the battery performance not of your concern, then you're going to consume more energy, definitely. So you can actually be sure of the performance of your CPU and the target application you'd like to use.
Okay. One more question before we get to the bike. Everyone wants to see the bike, but and do you have any power dissipation specs or kind of thermals and things like that for those dev kits that you mentioned? Or
we have a complex user manual. I would recommend you to check the user manual there. Yeah, it's not easy to know actually the power dissipation specification.
Right. Okay.
Yeah, so we do have user manual. You can check it there.
Fair enough. Yeah, so let's talk about the bike.
Perfect. So talking about the bike. So the concept of the e-bike, I think everyone having a bike or an e-bike, and basically today we would like to see what would happen if I combine sensors actually and plus AI at the edge. So if I took all of these and I created the models, I used the tools I mentioned before, how can I improve actually the e-bike, let's say, to make it a smarter e-bike? So I would say that we think of this concept in 3 ways. The first one is we would like to target the driver safety. And this is where, for example, you can imagine several application example or use cases where the idea here is that the user itself, like the person who's riding the bike, no longer needs actually to worry about all this surrounding. And we know that if you are driving a bike and you are also on a road where you are shared with the bus lane or the taxi lane or cars or etc., it's a bit stressful actually to drive a bike. And a lot of people I know that they're drifting away from the bikes when they live in a city that everything is shared actually with the traffic. So we can improve this experience, for example, by adding a vision vision sensor. Basically, we can add also microphones on it, and this will allow us to detect the blind spots behind you, or you can actually detect if there is an emergency vehicle. And you can imagine having, let's say, a screen in front of you, and it's doing detection in real time, and it can also tell you where someone is trying to overtake you. You can, for example, have notification directly from the bike, or having like the bike, for example, sending messages, or having like any kind of notification that can help you to understand that someone is coming from from the other side, they're overtaking me, or someone like is too close from behind, they're tailgating the person, and so on and so forth. Also, the second one is which is important, is the surface detection. So you're driving, for example, on a very nice road, but the road might change a bit. and you might need different torque. So the bike itself is going to improve a bit your safety by, for example, assisting you during this process. So this is when it comes only to the driver and driver safety. The second thing I would like to mention is the diagnostic of the bike, because as we are using the bikes every day, we'd like to monitor the condition of the bike in real time. And you can do that, for example, by having a vibration sensor attached, such as an accelerometer. And this is where I will provide more deep dive in the next slide. And by having a vibration sensor attached close to the gears and the chain, you'll be able to detect in real time, what is the status of the chain, what is the status of the gears, what is the status of my tire pressure, do I need, for example, to upgrade the bike? Is there anything I will need to do for my gears, for my chain? And usually when you ride the bikes, you don't think about it. You might go and do, for example, a couple of thousands of kilometers on your bike, but you never actually do the maintenance itself. And it's not really amazing to, break down in the middle of the trip or on the road, and you have like an important meeting, or you're targeting actually you're on vacation or you're going somewhere, and you find yourself in the middle of nowhere without a chain, without gear, or the air chamber of your bike has depleted. So you find it's not really a nice position to be in. So what you can do is by having, for example, an accelerometer connected to one of these AI kits, you'll be able actually to train an AI model and detect all of that. And the last thing is the personalization of the e-bike. You can basically do user identification, for example, by using the voice. So when you come to your e-bike, you have trained an AI model that detects actually your voice, and it has, let's say, anti-spoofing. So it knows you that it's you. It's not your voice that someone else has recorded. And it's only by having you personally, you'll be able to access your e-bike. It can also adjust actually according to the cargo, for example, providing you more torque for the motor, because, for example, if you have your kids with you on the bike, or if you have cargo, for example, you have did your groceries and you have them on the bike, it's a bit heavier now, so it can adjust itself and you don't need to compensate by yourself. So this is a concept itself where we can see a variety of application examples running on the e-bike. And you can see actually how these ones, all of them can work together. And you can even develop a model to detect several of these. And this is what we have been doing recently. So, this is, let's say, a prototype of a bike where we have took a vibration sensor. Basically, it's an accelerometer. We attach the accelerometer close to the gears on the second wheel. And you have also the chain that is going there. And we have collected data and built an AI model that allows you to detect two main things, which is the first one is the state of the chain, if the chain is deteriorating or not. And the second thing also is the status of the gears. Do I have any anomaly in the gear? What is the status of the teeth? They have been broken or not, etc., etc. And also, we are able to detect the status of the bike, if it's moving or not, if the frame has any looseness or not, so the structure of the bike is solid. And what we did is we collected the data set using the eBike RAAD1, which we have attached here under the seat, and we built an AI model. So we used the Renesas Real Time tools to build the model. We did the entire validation, and then we did the testing directly on the bike, and we were able to achieve an accuracy of 99.7% by only consuming 5 kilobytes of RAM. And this model actually is able to detect both of them. So we don't have two models, actually. It's one model that takes care of the gears and of the chain. And this is where I would see it as a starting point, where you can develop more into it, to have some kind of, let's say, a condition monitoring for your bike, running only on your, for example, AI kit, and using only one sensor. And the most interesting development will be when you have everything sensorless. You are not using the sensor itself, but you are using, for example, virtual sensor, where you can collect data virtually, or you are, for example, you have your motor control unit telling you, for example, the status of your motor. So more of these things actually could be developed when it comes to the e-bike. So this is, what I wanted to highlight regarding the e-bike. Yeah, so if you have any questions for the e-bike, feel free. If not, I would invite everyone to check our Renesas website. So we have a dedicated web page to AI, where everything we have, where Renesas and AI, you'll find it there. We have also released recently what I call a Renesas AI Hub, and it's basically an easy access page. If you'd like to have a quick look at our application examples, at the solution concepts we have, or the reference design, feel free to visit that one. And eventually, we have a YouTube channel where we publish videos from time to time regarding our tutorials, demos, walkthroughs, and new releases. And you will have when it comes to AI, I have mentioned actually the measure playlist. So this is the playlist name, the AI vision and the AI voice and real-time analytics. You can just write it on YouTube and you will get directly to that playlist. So awesome. This is everything I wanted to show you today, and feel free to go explore Renesas AI and let us know and start building.
Awesome.
Yeah, fantastic.
Very nice example indeed. Don't think we have more questions apart from that, but I did have more, obviously.
Go for it.
All the time.
Go for it.
For the voice AI kits, I think there was a distinction there that some of them were for voice comment recognition and the others were for something a bit more advanced, I guess, just because the first ones, I guess, were the keyword spotting, basically, in other words, and the other ones were more intent recognition, right? Like that.
Yes, exactly.
Yeah,
go ahead.
No worries. Continue.
So it's not like I'm not trying to distinguish between them. It's just like I'm trying to guide the user from the entry level AI kits to the highest level. If someone is interesting enough and capable of building a natural language processing model and trying to run it on the entry device, I'll be more than happy to see the performance and see how it goes. But it's just like I'm trying to guide you, what are going to be the one that are most suitable for your application, just from performance point of view.
Okay, I see.
There's a question here on the EU AI Act in an e-bike. I don't know if we have time in the last 2 minutes to get into the EU AI Act, but yeah, I mean, how are you thinking about some of the requirements of the AI Act in sort of your edge AI tools, or is that's like someone else's? I wouldn't say someone else's problem, but something else to solve further down the line.
Yeah, I know that the EU Act is, I think it's coming soon, and it's happening also. I'm not familiar actually with the specification related to the e-bike itself. I know there is a lot of regulations comes to the hardware itself.
Right.
So this is something that is, interesting to see. And, I'm not aware of the details. If it's
sounds like another live stream we need to do on the EU AI Act. Another question that came up: are the AI models hardware specific? So yes,
that's a great question, actually.
How specific are they?
All of these AI models, if you are developing them, you can deploy it on any Renesas hardware portfolio. Of course, you need to respect the hardware constraints. So, if you have a hardware that's not able to fit the model, then you cannot run it, of course. But all the models are designed to run on all Renesas hardware, even from the lowest end to the highest end.
Nice.
Yeah, what if it's not Renesas? Like you mentioned Cortex M33 or something.
Right. Or someone else using a U55 core.
Yeah.
Like, how portable is it to someone else's U55 ethos implementation?
You will not benefit from any acceleration there. So you will not be able to. I mean, if you can try to run it and try to build something yourself and spend like hours and days trying to fix it, but you will not benefit from acceleration. It might not work. There might be bugs. So the tools are designed actually and built for Renesas hardware. You will not be able to run it on different hardware.
Interesting. Yeah. Okay. Good. Well, this has been interesting. We're coming up on time, but thank you again,
Thank you.
Omar. And
Thank you very much. Thank you for having me today.
all right. Thanks, everybody. Take care.
Thank you.